Okay, so we're going to be doing problems for Chapter 10. Okay, Chapter 10 in the textbook. But before we go to the problems, make sure, go to like page 204 from Chapter 9, the previous chapter, right? We learned that pressure is a force per unit area, okay? So that's from Chapter 9, so make sure you understand that. So that would, force is equals to pressure times the area that over which that force is distributed, right? Now, but also if you look at figure 10.15, so work is equal to force times distance, we all know that. But then it's also pressure is equal to your change in volume, right? So here's a schematic of a cylinder that's where the gas is being compressed, right? So this would be like a square or a round cylinder. So it's a volume in there, it's three-dimensional. And you're compressing it. So your volume here has gotten smaller and you've compressed the molecules, so your pressure is going to increase because you have the same number of gas molecules in there. You compress it, now they're all squeezed into this, so your pressure is going to increase, okay? So make sure you just understand that on page 204, all right? So for what I'm saying, the homework problems that you'd want to be able to do for Chapter 10, right? So that would be on page 212, and you want to be able to do E1, E3, E7 and E11, and we're going to go through those right now. Let me just check the camera. Okay, let me check the camera. This is hokey, right? But that's what we're doing here. So, okay, question 1, E1, page 212. An object has a temperature of 15 degrees C. What is the temperature in degrees Fahrenheit? So we're going to convert from Celsius or centigrade, they can call it, to Fahrenheit, right? We both heard of both of those. Typically in the United States we use Fahrenheit for our common sort of every day-to-day things. In science though, you tend to use another form called Kelvin. We're going to get into that in just a second. So E1, right, this is page 212. So this is page 212. E1. Okay. So we're given that the temperature is 15 degrees Celsius, and they want to know what is the temperature in Fahrenheit. All right? Well, there's a formula they give. So temperature in Fahrenheit would be equal to 9/5 times 15, right? And you're going to use the degrees Fahrenheit plus 32. Okay, so it's just a conversion formula. So it's just going to be 9/5 times 15 plus 32. Now notice when you're converting the other way, make sure you look at the formula in the book. It's a different format, right? When you're converting to Celsius from Fahrenheit, the parentheses is in a different position. So I'm going to have you go look at that yourselves, right? Make sure because the math is a little bit different, right? So make sure you go check that out. And so you do that. That works out to 59 degrees Fahrenheit. Okay. To go from Celsius to Fahrenheit, I'll have you I want you to be able to do that, but you can go figure that out for yourselves. Okay, now we're going to do E3. Let me check the camera. Is all this showing up? Yeah. Okay. So the temperature in a residence hall room is 24 degrees C. What is the temperature of the room on the absolute Kelvin temperature? Kelvin is what scientists use, right? When I was in graduate school, everything is in Kelvin. Kelvin starts at 0. There is a 0 temperature, right? Where all motion except for atomic motion stops, right? So there is a 0. That is typically what is often used in science, right? So that is simply, you just take the degrees that you have in the Celsius scale, right? They want to know what is it in Kelvin. For Kelvin, you don't put the little degree sign, right? You will for Celsius or Fahrenheit, you put the little degree sign, but for Kelvin, you don't. It's just the way it is. You just don't. You just say Kelvin. So the temperature here would be 24 plus 273. And that gives you your value, your temperature in Kelvin. So this would be 297 Kelvin. All right? So make sure you can convert back and forth, right? I'll leave that to you. So make sure if you know the temperature in Kelvin, you can also convert it into Celsius, centigrade, and then from there you should be able to convert it into Fahrenheit, right? Okay, E7. E7. How much heat must be removed from a 200 gram? Notice here they're using gram, so that's okay as long as you're using grams for everything. You can stay in a gram system. You don't have to convert to kilograms, right? You got to use one or the other. How much heat must be removed from a 200 gram block of copper to lower its temperature from 150 degrees C to 30 degrees C? The specific heat of copper is, and they give you that value, right? All substances have a different specific heat capacity. So let's do that. So E7, right? So the question is, how much heat? So we're looking for Q, right? We're given the mass, we're given 200 grams, and then we want to know what is, and then we're given two temperatures. So what's our change in temperature? So our change in temperature is 150 degrees C minus 30 degrees C is equal to 120 degrees C. Okay? And then we're given C for copper. C for copper is equal to 0.093 calories per grams degrees Celsius, right? Okay. So we'll continue that up here. Let's make sure you can see all that. Okay. So now we'll continue that up here. make sure you can see that. Okay, so the quantity of heat Q is equal to the mass of the object times its specific heat capacity times the change in temperature. Capital T for temperature, okay? So that's going to equal 200 grams times 0.093 calories grams degrees C times our change in temperature, which we just figured out was 120 degrees C. Okay, so units, right? Grams cancel with grams. C, degrees C cancels with degrees C. All we're left with is calories. So this equals 200 times 0.093 calories times 120, right? And you get 232 calories left. Okay? That's number 7. So, number 7. Okay? And the last one, E11. So we're going to do number 11. And the question is, if 200 calories of heat are added to a system, how much energy has been added in joules? So that's just a simple conversion, calories to joules, right? So that's in the book, right? You can find it in there just like I did. It's written in there. You gotta read the book, right? So you set up, right, we've done this many times. So 1 calorie, you just pick away 4.19 joules. 1 calorie is equal to 4.19 joules. So, and they're giving us that 200 calories and it's equal to X. We're looking for that. And it's going to be in joules. Okay? So, multiply both sides by X. Then multiply, to get the X over here, multiply both sides by 4.19 to get that over here. Then divide by 1 calorie, and you end up with X equals I can zoom in on that a little bit, I think. $200 calories times 4.19 joules divided by 1 calorie from here. So look what happens. Calories cancel out. That's good news. You have 200 times 4.19 equals 838 joules. Okay. And then we'll just show you everything. Just to complete it. Okay, so here's everything that we did. Chapter 10, page 212, E1, E3, E7, E11. Okay. All right, folks, be safe.